Hello everyone, I welcome you all to this course Certification in Quantity Surveying, and we are learning about the quantity calculation. Starting from very basics, we will learn first of all that how to calculate the quantity for concreting in case of any footing. For now, we have considered these four types of footing. These are very common ones: trapezoidal, square and rectangular, stepped footing and the circular footing. So let us start with the one by one. So the first one, very basic, the type of foundation and most of the times used foundation is a trapezoidal foundation. So how we are going to calculate the quantity? At the right of the screen, you can see that are the dimensions of these foundations are given. Trapezoidal footing whose dimensions are 1 by 2 by 1.2 meter. Then the slope, the height of the slope is 1.3 meters. Then the dimensions of the column are 0.3 to 0.3 meter. So now how we are going to calculate the quantity? We'll be dividing this total footing into three parts. The first one will be the part at the bottom, that whose size is 1.2 meter by 1.2, that will be part 1. Then there is a trapezoidal portion whose part will be part 2, and there is other column portion whose will be the part 3. So let us take it learn them one by one. So how am I going to calculate the quantity for part 1? That is, the quantity calculation always takes from length into breadth into height. Okay, then if whatever the numbers are there. So for this one, if I want to mention, for the part 1, the length is 1.2 meter, that is mentioned here. The breadth is 1.2 meter, that is mentioned here. And the total height is, for this part, is 0.2. So that is 0.2. So whatever the multiplication that we are going to have will be 0.288 meter cube. The next one is a concreting for portion of this trapezoidal portion. So for that we have this formula, that is a h by 3. H is the height of that portion divided by 3 into a1 plus a2 and plus square root of a1 and a2. So now what is a1? A1 is the base area. Suppose this is the portion. So base area is this one, and a2 will be the top area, that is this one. So what is the base of this one is a 1.2 by 1.2, and what is the top of this one is a 0.3 by 0.3. So we have a area 1, that is a 1.2 by 1.2 meter, area 2 is a 0.3 by 0.3 meter, and the square root of this one, a1 a2, they're 1.2 1.2 1.2 0.3 and 0.3. And what is h? H is the height of this foundation, that is a 0.3 meter. So that is been explained mentioned over here. So when after putting these values in a formula, we get this quantity to be 0.189 meter cube. Then what is the third? That is a simple, that is column whose part is whose dimensions are 0.3 by 0.3 meter and whose height is 0.6 meter. So mention over here 0.3 by 0.3 and 0.6. The area comes out to be 0.054 meter cube. So now the total concreting in this foundation will be summation addition of these 3, 1, 2 and 3, that is a 0.531 meter cube is the total concreting in this foundation. The next one is a concreting in RCC footing relating to the square footing. The square footing is the simplest form, wherein we have only two squares to measure the quantity. There can be a square footing, or it can be a rectangular footing also. So based on that, you have to consider only square footing for the calculation, whose dimensions are 1.2 by 1.2 meter and whose height is 0.2. So we have this formula for concreting, as part 1 will be this foundation part 2 will be the part of the column. So we have this 1.2 by 1.2 by 0.2 for the part of this the foundation. That means 1.2 is a width, 1.2 is a height, and 0.2 is a 1.2 is a width, length, and 1.2 is a height. So based on that, we get this dimension has to be 0.288 meter cube. Then the concreting for part 2 is a concreting for column whose size is 0.2 by 0.2 and whose height is 0.3. The size is 0.2 by 0.2 and the height is 0.3. The total concreting of this one comes to be 0.012 meter cube. So addition of these two, both of them give me the total dimension of 0.3 meter cube. The next one is a other type of footing. We kind of use them in a situations where I have to cover more area. So in that cases, I am going to go for circular footing. The formula is simple. I will divide this into the two parts. Again, the same one. Part 1 to be the part of foundation. Part 2 will be the part of the column. So the concreting in part 1 is a and now the other thing is that the columns in previous ones were totally square or in a rectangular shape over here. So now over here at this one we have both of them are circular, means the column is also circular and the foundation also circular. So for that we have the formula pi by 4 d square is a total formula for the area calculation of the foundation, and if I multiply that by height of the footing or the column, I am going to get the volume of the concreting. The same is I am going to use it here. So the diameters are given are the foundation's diameter is 1.2 meter and the column's diameter is 1.1 meter. So both of them I am just going to put in. So pi by 4 d square into 0.2. 0.2 is the height of this foundation, and then 0.3 is the height of the column. Okay, I'm going to put the values of diameters over here. Diameter for this foundation will be 1.2, that has been explained over here, then 1.2, and the diameter for the column is 0.1. So I'm just going to put the values total, and the total area calculation will be 0.268 meter cube. So this was a very basic and crisp idea about how to calculate the quantity related to the column and foundation calculations rather. And so these are very common types of footings we have. There will be a pile footing, or there is a pile footing also, on which we are going to work out on a whole project. So I haven't considered this pile footing calculation into this one. We'll be having it at the end of the session itself. With this, I wish you all the best. Thank you so much.